Now we look at questions number 2. Okay, this is a bit tricky. This is a bit tricky. However, I think it's manageable, and also that you might need to revise your O-level text, AMAC text, if you really have problem in following out. So this is fx equals to tangent arctangent square root 2 plus x. So they'll ask you to find out what is f ply x and what is f ply by x. Okay, so how do you do that? First of all, you need to know the formula of f ply x. Fx equals to tangent x. What is the derivative minus? So arctangent x. What is the derivative? The derivative is that it is 1 over x squared. Okay, so you need to remember this. This is a must remember formula. You see, I don't even refer to the formula text. So what you need to do is that, okay, you need to differentiate those things. So f ply x is equals to d dx arctangent square root 2x square root 2 plus x. So applying chain rules, okay, du dx times dy du equals to dy dx. This is called chain rule. In A level, in O level, you do not know the rule is forgivable, but in A level, you need to understand this rule. So which means that this is you need to differentiate internally. Then this become dy du. Okay. So you don't go and so this is constant. You differentiate square root 2 is 0, right? Plus 1, then you go and differentiate inside lah. Don't be lazy lah. Okay, anyway, it's okay. Anyway, you cannot be lazy lah. Okay, so this become this thing. It's very nicely done, right? But you bear in mind that you got a constant here, so in fact we should make it more presentable, because of the square root 2, you square it become 2. So you also remember you have this formula, right? Or if you don't have this formula, you don't know this formula, better go and study, because you're going to fail if you don't know this. Can guarantee that. So now if we do that, okay, so how do we go and differentiate this? Differentiate this is very simple. We treat it as a u here. You differentiate this again, and this is 1 plus 1 over 1 plus u squared. So it become 1 plus u square. You let u equals to this. Okay. So then du dx become 1. And you know that this is in the denominator, so it's minus 1. Okay, so got it. Your calculus, you have to practice, no matter how. Okay, you have to practice your calculus. Okay, so this is 1 minus 1 plus 1 plus, okay, square root 2 plus x squared, perfect square, and minus 1. And this, when you differentiate this term, it become 1, because this is constant, this is x. So what you get, minus 1 plus square root 2x square 2. See, now you get this very neat term here, because you have a constant x here, so it won't give you x squared plus something. Initially when I did this thing, I go and expand everything, but look very messy. So why? Because the next question we are going to find out is the Maclaurin series. They give you the first 3 terms. The first 3 terms involve what? F naught, f ply naught. Okay, f ply naught. Correct. So these are the first 3 terms. So then what do we get here is that we can substitute f naught here, which is become, you put in 0 here, arctangent square root 2 plus 0 no need to use a calculator, is pi over 4. Is it pi over 4? It may not be. So I'm sorry, pi over 4 is arctangent 1. So this is my fault, okay? Forgive me. So this is arctangent. So tangents, arctangents 2. So the f pi naught, what do you have here? We can refer to this formula. You sub in 0 here, become 1 over square root 2 with 2, it is 1 over 1 plus 4, 1 plus 2, so 1 over 3. F pi is not, it becomes, you sub in 0 here, which gives you 1 plus 2 square. So 1 plus 2, 3 square is minus 1 over 9. So, but you look at the side, did we make any mistake? We did not. Okay, somehow we make careless mistake in life as well. So, so I'm sorry, here we still need to differentiate this, because du dx, just now I put this is a square here. I forgot to differentiate the square here. 1 over square, 2 square, so there's a 2u here. Then we also have the 2 times square root 2 plus x. So square root 2 plus x, when you sum in 0 here, this is 2 square root 2. Yeah, you need to have this thing. Okay, so Maclaurin series state that you have the function is equals to summations of this n factorial, and this is xn, where n equals to 0 to infinity. So now the first 3 terms we have it, so we can just sum it out. Okay, seeing that this is fx, so we get tangent arctangent square root 2 plus 1 over 3 x minus 2 over 2 square root 2 over 9 times 2 factorial x squared. So 2 factorial actually is 2. So you punch in a calculator, what you get is that you get 0.955 plus 0.333x minus 0.157x squared. So you get it down already. Easy peasy. Okay, thank you.